David Merrill, an instructional effectiveness consultant, developed the instructional design model, which we know as Merrill's first principles, in 2003. This model can be described as a meta-theory, as he created the model by identifying principles that were common in other instructional design theories. His underlying assumption was that if a principle is founded in multiple theories, then it's been proven valid through either experience or empirical research. Since Merrill is creating a meta-theory, he doesn't identify any particular theoretical base for his own work, but his approach has affinities with Wittgenstein's idea of family resemblances. To understand this concept, it's helpful to think about how children in a family resemble each other. In most cases, siblings don't look identical to each other, but due to genetics, they will have some features in common. In a similar fashion to a family, Wittgenstein argues that a category of items that appear to be connected by an essential feature are actually linked by a network of overlapping, crisscrossing similarities. Wittgenstein's classic example is games, as he shows that, say, sports, board games, card games, and childhood games don't have a single feature in common, but rather draw from a group of features. Likewise, Merrill remarks that no one theory contains all of his first principles, but all of the theories contain some of the principles. As a result, his model is the result of observing family resemblances in instructional design. Merrill's first principles start first with the assumption that learning occurs when the learner is solving a real-world problem. Learners then move through the four instructional phases: activation, demonstration, application, and integration. The real-world problem is always at the center of the learning activity, however. The first 5 principles are summarized in this table. The bottom row provides an example, which we will describe in the following slides. The first principle relates to this type of instruction, problem-centered. In the first principle, Merrill describes that learning is promoted when learners solve real-world problems. The 3 corollaries listed on the screen describe further ways in which problem-centered learning can occur. So let's imagine that an instructor wants learners to think about urban planning and how it can help solve transportation problems or ecological issues. Following the 3 corollaries, the instructor might invite learners to consider a city which wants to encourage residents to use bicycles in order to decrease congestion on the roads and cut down on emissions. Learners would be asked to solve this problem and encouraged to think about how they could apply their skills and knowledge to the real world. They may start by considering how to solve the problem for their campus or neighborhood, and then adapt that solution for other environments in the city. Moving into the second of Merrill's principles, we understand that learning is promoted when learners are able to activate existing knowledge to build upon. This is the first stage of an effective instruction, activation. The corollaries in this stage provide suggestions of how instruction can be designed so that learners are building on past knowledge. Using our bicycle example, learners may be asked to reflect on their own experience riding bikes or to ponder why they drive places. This reflection activity would coincide with the first corollary. In the third principle, or the second phase of effective instruction, Merrill suggests that learning is promoted when the new knowledge is demonstrated to learners. Using our bicycle example, the instructor might assign a video for learners to watch, which describes the concept of a bicycle-friendly city design. This learning activity would be an example of the third corollary. The third phase of effective instruction, or Merrill's fourth principle, states that learning is promoted when learners apply new knowledge. At this stage, learners could create a list of ways that the city can become more bike-friendly, brainstorm in groups the pros and cons of each implementation of the change, and then narrow down their list of recommendations for action. At each stage, the instructor could provide relevant feedback on their ideas. The final principle states that learning is promoted when learners integrate new knowledge into their world. To conclude our bike example, the learners could develop a 3-minute persuasive video describing specific ways in which the city could change to become more bike-friendly. They could then send this video to the local city planners or post it on a local community forum or show it at an event on campus, thus publicly demonstrating what they have learned. In addition to the 5 first principles of instruction, Merrill identifies 3 basic properties of his principles. Specifically, he claims that the implementation of these first properties promotes effective learning, that these first principles can be applied to any system or environment, and that they need to be taken into account at the design stage. But are they equally good for all contexts? In fact, Merrill's principles are best suited for formal learning contexts, where instructors are leading learners through instruction and content and presenting them with only somewhat authentic environments in which to consider real-world problems. In other words, they work best in cases where an instructor is involved to ensure that the problem is actually solvable, does not require the learners to use too many areas of skills and knowledge, and does not introduce additional complications that would increase the cognitive load. As a result, they may work less well in certain corporate learning contexts, such as on-the-job trainings, where a blend of informal and formal learning may be taking place, and where participants may work with problems that are not solvable or that require additional expertise that the course is not designed to develop. When Merrill's first principles were used in Shell's corporate training program, the instructional designers found that they needed to expand upon them, as depicted in this diagram. For instance, they noted that they needed to think more about collaboration among learners and colleagues, and about knowledge sharing and learning from experts, mentors, and others in the organization. They needed to involve other stakeholders, such as learners, supervisors. They also observed that they needed to think about how to accommodate learners with diverse needs due to differences in their professional experience, regional and geographical demands, and cultural backgrounds. Lastly, they needed to think strategically about how to use materials in the workplace and the available technology. Overall, we were interested in this model further for several reasons. First, the model provides a simple overview of the learning process, which makes it easy to comprehend. Second, because the learning is grounded in real-world situations, learners may be more motivated to engage in the material and address important issues. Third, the end process of integration is the ultimate proof of mastery of whatever the problem is solved. When one can integrate newly learned material on a regular basis, they have conquered the unknown of the original problem. No one instructional design model is perfect or without limitations. For Merrill's principles, there are several drawbacks. First, it's debatable whether all instruction can or should be centered on real-world problems. For instance, certain disciplines involve the study of abstract concepts, which can help train habits of thought that are useful in real-world contexts, but which do not have real-world applications. For instance, pure mathematics is distinct from applied mathematics precisely because it is unconcerned with real-world applications. Moreover, not all real-world problems have solutions, and it can be difficult to select a real-world problem which is uncomplicated. A related drawback is that the exploration and learning is bounded by the original problem to solve. That is, learners may be traveling down bunny trails seeking answers to complicated problems, or they may be limited in their exploration of the problem because it's not actually relevant. Likewise, extensive scaffolding may be required at multiple steps in the problem or in the model, especially if the real-world problem is far out of reach of the learners. Equally, learners may not have sufficient prior experience with a particular problem, which would create problems in the activation phase. These limitations can be overcome by selecting a real-world problem which has a definitive answer and with which the learners have some familiarity. The instructor still needs to be able to teach new material, but it should not be so far removed from the learner's previous knowledge base that the instruction cannot begin at the activation phase. Finally, Merrill's first principles do not provide much guidance about how collaboration or peer-to-peer instruction promotes learning, which means that they need to be supplemented by social constructivist theory in certain contexts. They also do not consider how different learners might have very different needs. As a result, Merrill's first principles are widely applicable, but they do have certain gaps that require supplementation with the other instructional design theories that we will hear about this week.